Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. This is the second time I taped this session. Midway through the session, it stopped, and it told me I don't have enough memory. Yeah, I know I'm getting old and have amnesia, but I didn't think I didn't have enough memory for that. Anyway, jokes aside, what I'm going to do today is to go over matrices again. But this time we are going to discuss how we factor a matrix into two smaller matrices. One of them is a lower matrix and one of them is an upper matrix. We call that the LU factorization. And you will see why we are going to use that in solving systems of linear equations next time. So today I'm just going to show you how you factor a matrix, and then next time we'll see how we can use that to solve a system of linear equations. And you said, but haven't we done that already? Yes. In the same playlist, you will find three methods. Basically, we use the Gauss-Jordan elimination method. We use the method where you invert the matrix and multiply it by the right-hand side. And then we did Cramer's rule, which uses determinants of matrices. So why another method? Okay, well, basically you need to know more than one way to solve the problem. So I'm going to write the matrix here, A matrix, and maybe you take another couple of examples. So they are 3 by 3 to make it, worthy of doing, because 2 by 2 is trivial. So let's say 1, 2, 3, 4, 5. I know what you are waiting for, the next two numbers, but I won't give them to you. So I would say 6, but then I go 3, 1, -2. Now I'm going to divide that into two matrices. I'm going to call the first one L for lower, and lower matrix will have 1 along the main diagonal and 0 above that. Only lower, only these three values. The upper, on the other hand, will have zeros on the top. I'm sorry, zeros at the bottom, and I fill in the top. Here we are going to use Gauss-Jordan elimination method to make this a row echelon form, in row echelon form, not reduce row echelon form. No, just row echelon form. So the first row, I'm not going to do anything to it, right? It's just 1, 2, 3. Then we are going to say, I need to make these two numbers 0 first. So I'm in the first column. And I told you when we did the Gauss-Jordan, if you are in a specific column, if you want to delete a number in a specific column, you are only allowed to add or subtract multiples of the first row. When you go to the second column, it's second row, third column, third row. So you never go into a vicious loop or vicious cycle. So we are coming here and say, okay, I want to get rid of the 4. Notice these three numbers, I want to get them 0. So let's start with the first column. I want to delete the 4, so I'm going to subtract 4 row 1. Why row 1? Because I am in column 1. So whatever I subtract here, the number that I subtract, or the multiple of row 1 that I subtract, will be written here. So I would write a 4. How many row 1 did you subtract? I subtracted 4. So you write whatever you subtract. Okay. And then you say, okay, 4 minus 4 is 0. 5 minus 8 is -3. 6 minus 12 is -6. I'm done with the second row. Then to get rid of the 3, I need to subtract 3 row 1. So I come here and write 3. That's what I want to subtract. 3 minus 3 is 0. 1 minus 6 is -5. And -2 minus 9 is -11. Okay. Now, I'm going to go back and I need to fill this number. So let me rewrite it again to make it clear to you, okay? Here, I have 1, 2, 3, 0, -3, -6. And here I have 1, 0, 0, 4, 1, 0, 3, blank 1. Now, I want to get rid of the -5. So I need to multiply the top by 5/3 and subtract it. So I'm going to subtract 5/3 row 2. Notice I write here what I subtract. I subtracted 4, I subtracted 3, and now I subtract 5/3. 0 minus 5/3 times 0 is 0. -3 times -5/3 is +5, minus 5 is 0. -6 times that is 6 times 5, 30, divided by 3 is 10, minus 11 is -1. I'm done. That's the factorization. I'm going to keep this paper for next time, because next time you're going to use the same. I'm going to say, for example, that the first equation is x1 plus x2 plus 3x3 equals something, and so on and so forth, and solve. Now, let's take, this is what I was doing before when it stopped. Okay, I think I have another one. I have a matrix here. Just I want to make sure that the matrix, let me do it here so we can use the same paper next time. This matrix, oh my God, is 6, 18, 3, 2, 12, 1, and 4, 15, 3. So like we did before, I need the lower. That will have 1, 1, 1, and then zeros here. So I can fill these from the get-go. And then I have an upper that we can start with right away. However, just to make life easy for us, okay? I see that these three numbers are divisible by 3. Right? So next time when we solve a system of linear equations, I'm going to say 6x1 plus 18x2 plus 3x3 equals a number divisible by 3 just to make life easy. And I'm going to divide that by 3. You don't have to. You can leave it as 6, 18, 3. But I'm saying it's make life easy. Instead of multiplying numbers by 18, I can multiply. You know what? I'm not going to change it. I don't want to. So you can see that it doesn't really matter. The only problem is that you see when these numbers are large, you will be subtracting fractions of row 1 instead of multiples of row 1. So that's why I didn't want to leave it as 6. But anyway, we are going to say the first row stays the same. Let me leave it the same. And then here, I'm going to say subtract R1 over 3, because when I divide 6 by 3, I get 2. And if it's -2, I can get rid of it. So here, I subtracted 1/3. So this is 1/3. That's why I wanted to divide the first row, simplify it, and make it 2, 6, 1. But again, it's not a big deal. Okay, so let's do that. So 2 minus 6 over 3 is 0. 12 minus 18 over 3, which is 6. 12 minus 6 is 6. Oh, I wanted to use this color for the upper and this color for the lower, just to make it easy. And then 1 minus 3 over 3, which is 1. 1 minus 1 is 0. So I get 0, 6, 0. Now, to get rid of the 4, I need to subtract 2/3 of R1, right? Because 2/3 of that is 4. So here I'm going to come here and say 2/3. And I say 4 minus 2/3 of 6. We pick that to be 0. 2/3 of 18 is 12. So 15 minus 12 is 3. 2/3 of 3 is 2. And 3 minus 2 is 1. So now I'm done except for this 3. So let's rewrite the lower 1, 0, 0, 1/3, 1, 0, 2/3, 1. And then for the upper, I'm going to write the first 2 rows. In fact, I can write the 0 also. It will never change. And say, okay, to get rid of the 3, notice I'm in the second column. So I add or subtract multiples of the second row. It's a 6, so I need to divide it by 2 and subtract. So I'm going to subtract 1/2 of our, I have to write it here. Subtract 1/2 of R2. And because I'm going to subtract 1/2, I would write here 1/2. And then say 3 minus half of 6 is 0, and 1 minus half of 0 is 1. And I'm done. However, I want to check. So for example, if I multiply these two, would I get the same matrix? Let's quickly do that. 1 plus 0 plus 0 is 1. 2 plus 0 plus 0 is 2. 3 plus 0 plus 0 is 3. So the first row is easy because we didn't change anything. Second row, 4 plus 0 plus 0 is 4. 6 minus 3. So here I did something wrong. Why did I end up with that? This should be in -3, yes? No, it's correct. I said 6 instead of 8. I thought this is a 3 for some. I was using that. 8 minus 3 plus 0 is 5. 12 minus 6 is 6 plus 0 is 6. So the second row is okay. How about the third row? 3 plus 0 plus 0 is 3. 6 minus 5 is 1 plus 0 is 1. 9 minus 10 is -1 minus 1 is -2. So this is correct. Let's check this one because it has fractions. 6 and 0 and 0 is 6. 18, 0, 0 is 18. 3, 0, 0. Again, the first row is easy. Second row. Third of 6 is 2 plus 0 is 2. 1/3 of 18 is 6 plus 6 is 12 plus 0 is 12. 1/3 of 3 is 1 plus 0 is 1. Finally, 2/3 of 6 is 4 plus 0 is 4. 2/3 of 18 is 12 and half of 6 is 3. 12 plus 3 is 15 plus 0 is 15. 2/3 of 3 is 2 plus 0 plus 1. 2 plus 1 is 3. So it's correct. And basically that was a short session, but I wanted to go over it to make sure you understand how you break a matrix into lower and upper. Next time, I'm going to add just the right-hand side and ask you to solve for x, y, z. So this matrix is multiplied by x1, x2, x3, for example, and it has a right-hand side. Okay, using this method, not using, of course, the 3 methods that we learned so far. I hope this was an easy session. The last one was really long. The one I did on eigenvalues and eigenvectors was very long. So at least now I compensate. I don't want to be I don't want the sessions to be too long for you. So thank you very much for your watching, and I hope you learned something today. And if you have any questions, again, as usual, don't hesitate to leave me a note in the comment section, and I will get back to you as soon as I can. Thank you very much for your time. Hope to see you soon. Have a great day. Bye. Oops.